So this is question 11 from page 323, which is very similar to that one in my open math. And there's two ways you can do these problems. You can do one here. Let me find that. Let me find my pointer here. Okay, so you can use just the plain old a b to the x. We're going to find some base, and the initial value is a, and then x. I guess I could use t there also, since this is about time. And so if I were going to do that, well, let's see. I know I've got here. Let me come back here, and I'll just use. I won't use. So I know that at time 0, I have 1,500 bacteria. And that's going to be true either method. And then they're telling me it doubles in size every half an hour. So in 30 minutes, I'll have 3,000. So I could do the same old that we've been doing right along, where, let's see, I know y is 3,000. And then I know initially I have 1,500. And I have b raised to some power. I'm going to switch the x to a t just because we're dealing with time. Doesn't matter, but I'm going to. So then 3,000 divided by 1,500 is 2. And actually, you know what? I messed up here. I'm realizing now. I hope that's not. You probably caught it when I said that. For when y is 3,000, x is 30. So I should have done that. But now I knew I was wrong because I had two variables there. I'm going to take the 30th root of 2, and that'll be my base. And let's see, on my handy dandy calculator, I'm going to do 2 raised to the 1 divided by 30 power, right? Rewrite it as a rational exponent. So that gives me 1.0234 I'll go with. So it's about 1.0234. So I've got an equation, y equals 1,500 times 1.0234 raised to some power x or t. And then after 2 hours, I'm just going to replace the t. Now, t is defined in minutes, right? I guess I didn't say that earlier, because I'm going 0 minutes and 30 minutes. So t is going to be minutes. So for 120, 2 hours, I'm going to write 150 or 1,500 t times 1.0234 to the 120, and then crunch that on my calculator. And then 100 minutes, I'll just replace the t with 100. So that's doing it the same way we've been doing it right along in this David Lippman materials in this textbook. Another way to do it, and sometimes I'll do it if I think about it. I know that doubles in size every half an hour. So I know I'm starting with the same initial value, 1,500. And then if I have one 1/2 hour period, 1 30-minute period, it's going to double once. So, and if I have an hour's worth of time, and so that's two 30-minute periods, I can think about that as t defined in minutes. So 1,500 times 2 raised to 60 minutes. If t equals 1 hour, if I've got 1 hour's worth of time, I'm gonna do, so t is equal to 60. So 60 divided by 30. Well, that's going to be 2 doubling periods, 2 to the second. Okay, and then for 2 hours, I'll do what's 120. So I'll do 1,500 times 2 raised to the 120 divided by 30, which would be 4 doubling periods. Right. So this method seems easier, but it only works when things are doubling. It also works with half-life too. You can do the same thing with half-life. I'm sure you've done that. I encourage you to go into the textbook and take a look at some of these questions and get some practice with them too before you try to do the MyOpen Math. I think you'll find the MyOpen Math goes a lot easier having done this practice. But I hope this helps you out, and give a yell if you need some help. And remember, I'm out of e-tutoring Thursday, Friday, Saturday, Sunday. I'm sorry, Thursday, Friday, Saturday, and then Monday night.